All right, hey guys. My name is Dan. I'm an appliance trainer over at ApplianceTechAcademy.org. Today we're going to be talking about Whirlpool Maytag top-load washers that don't want to start cycles. So in this training content, we're going to be discussing some of the logic behind the symptoms you're seeing, and we're going to look at how to zero in on where the issue is rather than throwing parts at it. So some of the common complaints you're going to see on these units is the lid either won't lock, it won't start a cycle, won't drain, or you're going to see some error codes like F7E1 and F9E1. This is a pretty common issue with these units, and we're going to dive into why. So some of the scenarios are the customer might go to start a cycle, the lid locks, then unlocks, maybe an error code appears. Or maybe the customer comes back mid-cycle and the washer's not running. There may be some water in the tub, they try to cycle power to it, or maybe even try a drain and spin. Sometimes it'll work and other times it won't. So our initial thoughts on a no drain would of course be the drain pump. It would be where we'd be focusing our efforts. So, the thought is if it has a failed drain pump, it's getting voltage but not kicking on, then it's got to be the issue. Now, what I'll say is most of the time with these units, the drain pump itself is not the issue. Not saying I haven't seen failed drain pumps on these before, but based on the symptoms that we're looking at, most of the time it isn't. So up next, the next thought would be, hey, lid's not locking. In the scenario where the lid locks, then unlocks, your initial thought might be the lid lock failing. And if the lid switch is not bad, then that leaves the board, right? Again, most of the time, no. Most of the time, it's neither. So to understand why it would be neither of those, we need to understand the board logic behind what's going on. So when the user starts a cycle, the control board makes some checks before it actually starts anything, and it's checking to ensure that all the relevant loads are present. Most of the time it locks the lid, then makes the checks. So within a second or two after the lid is locked, if it's seeing an open circuit, it's going to unlock the lid and then present an error code. So in theory, this makes sense. If it's seeing an open circuit for, say, the drain pump, then it's not really logical to fill the unit up with water. Same thing with the shifter. If the shifter circuit's open, it won't be able to shift. We won't be able to go from shift or wash to spin. So why waste the resources on a cycle if it's not going to get to the important functions that need to occur? So some common diagnostic mistakes that I've seen is it's easy to see that the lid is not staying locked and assume it's either the board or the lid lock. But what happens when you replace those parts and the unit's still doing the same thing? So now that we understand some baseline logic in the board, this might explain why the lid's not locking and why it's not staying locked, and it will kind of help point us towards the next steps we need to take. So we would want to see what the board is seeing. We would want to understand why it's not wanting to lock the lid, beyond chalking it up to a board issue. Remember, boards, they look to the sensory input devices that they have. That's all they can see. They don't have eyeballs. If they're seeing an open line on a drain pump, you can replace the board as many times as you want. The new board is going to do the same thing. It's going to look to the drain pump, it's going to see that it's open line, and it's going to do the same thing. So our goal as appliance technicians is to prevent replacing unnecessary parts. So that brings us to a technical service pointer that Whirlpool has put out. And this pointer kind of details a known issue with the lower wire harness on these units. And typically it ends up being the blue wire on the lower wire harness, and that's to the drain pump. And we're going to kind of dive into that here in a moment. But the pointer pretty much directs you towards checking out that lower wire harness. And some of the times the break is clear. It's right at the drain pump. The wire that goes into the drain pump popped loose, or it's broken there. It's severed, or it might be even severed a little bit further up. You can see you get the blue wire, black wire come up right through there. I've seen it broken up there a few times, sometimes right at the drain pump, sometimes a little further elsewhere. A lot of times that happens because the unit's shaking around a lot during spin and a wire just pops loose. Maybe they didn't have enough slack. The reason why, not too sure. What we're looking for are solutions here. So other times it's hidden in the wiring. Sometimes you won't even be able to see it. And that's why I always prefer the meter tests over a visual test. Sometimes a visual test will show you what it is, but if it's not and you start replacing parts just to find out there's a broken wire right up here, then you've wasted a lot of time and money on that. So before throwing parts at the unit, How can we make effective diagnostics to actually really zero in on where the issue is if we do suspect a broken wire? And we're really going to dive into that here in a moment. So let's say we have an F9E1, which is a long drain. If you got that code and the unit's not draining, guess what? We can check the drain circuit right from the control board. There's really no need at this point to tip the unit back and spend a whole bunch of time visually assessing everything. Because what happens if you see no broken wires? Then what? You're kind of starting to replace parts and get a little frustrated. So what we can do when we have the wiring diagram in front of us, we can make all of our checks right from the control board. And that's going to show us what the control board sees. Again, the control board doesn't have eyes. It doesn't have eyeballs. It can't visually look at all the wiring to see. And sometimes our eyes deceive us. Sometimes there's wires that are hidden in things. So if you see no broken wires, then what? So for starters, what we want to do is we want to locate the connector on the control board. We can see here it's the J6 connector. Right over here it tells us we got the motor, we got the shifter, we got the drain pump, the other motor winding, nothing there, and the neutral. So this J6 connector is where we'd want to take a look at. Now, when you're reviewing a diagram, finding the right connector is really just a matter of tracing out your circuit. And it's pretty basic. When you have a 120 volt drain pump, you know it needs line and neutral to kick on. That's all you need to know when you're looking at wiring diagrams. So we have the drain pump right here. We know it needs 120 volts. So the question is where is it getting that 120 volts? Well, if we do it one by one, we have this line, comes out, comes up, boom, right there. Look at that, J6. It's kind of tough to see in this diagram, but it's a light blue wire, J6, light blue. Okay, cool, we've got that one done. Now the next one, this will probably be our neutral. Comes up here, over here, comes into a splice, and you can see this splice also provides neutral to the shifter and over here to the motor. Nonetheless, we're not really worried about those. We're only worried about, right now, the drain pump. So tracing that out, comes up here, splices in there, and then it comes up right there. So the same connector we were just looking at, blue and white. That's how easy it is to use a wiring diagram to figure out how to test a load and how it gets this voltage. Now the cool thing about this is we don't need to tip the unit back, pull the connector off, get a resistance reading across that. We can do it right from the control board at those two test points. We can disconnect that connector and check resistance. So one other thing to say on these units is we've got this filler stuff here. It's there to prevent moisture from getting on the board and causing it to do anything. Now the issue is you know, we're looking for the J6 connector, but there's no pinouts. You don't see any callouts here. This is where it's just a simple process of elimination. You're just using deductive reasoning to determine which connector this is. So for starters, we got 6 pins. So what we can do is we can look over here. I can't really see how many pins that one has, or that one. That one's got 3. This one has, you know, maybe 8. This one right here, look at that, 6 pins. That one's got 2. The other thing to consider when you're, you know, because we might be confused. Maybe that has 6 pins. Maybe that one does. I can't really tell from the picture. But look at how small these are. These are for low voltage loads. We're not going to be putting a whole bunch of current through these. And on this connector right here, we've got the motor, you got the drain pump, and the shifter. Those are all high voltage loads. They require 120 volts and they use quite a bit of current. You can't get too much current through these little pins. So by process of elimination, this is going to be our connector. And what you can also do is compare the wire colors. Now, one other thing that I have seen is techs get confused. Oh, it says white right here, but I have a black wire there. Or this one has a black wire with a white tracer, but I'm seeing a white wire. It's not lining up. Well, if all the other ones line up, and that's the only connector, then clearly that's going to be your connector. Most of the time I see this one being different. These are generally all the same on these units. But just throwing that out there, it's really a process of elimination. Don't get confused or scared if you're not entirely sure because it doesn't say right there J6. It's a process of elimination. We found it. So let's take a look at our drain pump circuit. We've already traced it out before, but we can see drain pump right there, neutral circuit right here. Okay, so what we would do is we would disconnect this J6 connector. It's going to be that one. We're going to disconnect that from the control board. That way we're isolating the circuit. And then we're just going to get a resistance reading on it. Now, this tech sheet is nice enough to actually show us about 17 to 21 ohms. So we'll say it's 20 ohms for our drain pump. So same thing with the shifter. If you want to do the shifter, it shares the same neutral, and it's just going to be that brown wire. And the shifters, I think it's 2 to 3.5 k ohms on this one. If you've got a magnetic clutch shifter, it's not going to be 2.5 k ohms. It's going to be somewhere in the mega ohm range, and that's just because it's got a rectifier in it. We're not really going to get into that too much here, but on this one, and you can see right there, 2 to 3.5 k ohms on our shifter coil. And when you're looking at the diagram here, this shifter coil is our load. All these are just kind of for optics. We're not worried about those for this. This is right here is what actually shifts from wash to spin. And you can see connector comes to pin 3, black wire with a white tracer. On the other diagram, it was showing white as the neutral, and then brown wire. Point aside, let's go back to the drain pump circuit testing. So in a perfectly good circuit, if we have the J6 connector disconnected from the control board, and we get a resistance reading across the light blue wire and the white wire, we should have about 20 ohms, plus or minus. Anywhere that's close to that, you should be good. Where you're going to have an issue is if you see open line. If you're checking across those two and you have open line, that means either your drain pump is bad or your wiring is bad. If you get an open line, that's when you're going to need to tilt the unit back and check across the drain pump. If you're getting 20 ohms at the drain pump but open line from up here, then you've got a bad wire harness. And this is basic diagnostic process, your steps to figure out what the issue is rather than just throwing parts at it because, oh, I worked on a different unit that had the same issue. It had a bad drain pump. If you're taking that diagnostic approach, you're not actually diagnosing appliances. You're just making guesses. You're throwing things at it. We have a meter for a reason, to make these checks. So let's kind of go over to the lid lock. If you're dead set on the lid lock being faulty, you can check that circuit from the control board to see if it's opened or closed. And we do have a more in-depth video in the training program over at Appliance Tech Academy, where we really detail how this whole circuit works, what the switch does, what this switch does, whatnot. But for the purpose of simplicity and for this training module, we have the lid lock solenoid right here. We have the lid switch. When the lid is shut, our lid switch is shut, and it completes this circuit. When the control board needs to lock the lid, it sends 120 volts down this line to this side of the solenoid. Neutral is provided through this side of the solenoid. When the solenoid has line and neutral, it engages. When it engages, it pulls this lock switch shut, and then the control board is seeing 120 volts coming back through. So if the lid lock is working, you'll see 120 volts come back through here because it engaged that lock switch. Point being is when you're testing a lid switch, all you really need to do is disconnect this J4 connector from the board, 3-pin connector, red, white, and blue. Let me actually go back up here because I've seen this mistake made a few times. 3-pin connector, 3 wires, red, white, and blue. The other thing that can trip you up, sometimes the water inlet valves have the same colors, red, white, and blue. Probably on that one. Just understand, the lid lock, about 50 to 100 ohms of resistance. It's going to be a higher voltage, more current going through that. Most of the valves are 1 k ohm, so they can use smaller wires to effectuate their operations rather than the lid switch. So again, just keep an eye out for that. And then let's go back over here. There we go. So if you're testing the lid lock from the control board, all you need to do is disconnect that connector, get a resistance reading from here. Our tech sheet shows us it's about 50 to 160 ohms. Most of the time I'm seeing right about 100 ohms, 99 ohms, plus or minus. If that's good, it doesn't necessarily mean your control board's the issue quite yet. Again, if the control board is seeing an open line on some other circuit, then we've probably got something else going on. So with that being said, you can also go into diagnostics and manually lock lid locks. If you run a diagnostic cycle, if you're getting an F9E1 code, if you're getting an F7E1 code in diagnostics and it won't lock the lid, guess what? If it's not giving you a lid lock code, your lid lock is probably not the issue. You need to check more into the drain pump or the shifter before just saying, hey, it's a bad lid lock because it won't stay locked. So when it comes to repairing appliances and you suspect a certain load, let's say the lid lock is being faulty, most appliances do have service modes or component activation modes, depending on which one you're working, and it's really not that hard to verify the operations of certain loads by simply navigating to the menu rather than taking things apart to make checks. And when you're lost, just remember, you want to figure out what the appliance is doing and what it is not doing. If it is locking the lid, albeit for just a second or two, then our lid lock's probably working. If it's not draining, no matter what selection you choose, then you probably have a drain pump issue or a wiring issue. So let's kind of go back through and talk about a logic approach. You got a tub full of water, lid is locked. So if you arrive to a service call and the unit's full of water and the lid's locked, you'd want to try to activate the drain pump. We want to see if the drain pump works. And you can do this by trying, say, a drain and spin, or you could go into diagnostics. On these ones, diagnostics are mostly automated. You can't go through, so far as I remember, and activate each load individually. But if you're not getting any motion on the drain pump, it might be time to check that drain pump circuit from the control board. And we just went over all that. So, in another tech tip, if the lid is locked and the tub is full of water, you can often disconnect the pressure tube from the control board and then cycle power. A lot of times this will open the lid for you, and that's pretty much just the control board seeing that the tub is full of water, and it's a safety program in there to keep the lid locked. So, let's see here. Up next, if you're seeing a long drain fault, F9E1, the code is going to kind of look like this. You got the lid lock illuminated, sense and done, and then lid lock off, just done. That's going to be F9E1. When it comes to binary code, they can be a little confusing. And over on ApplianceTechAcademy.org, we actually made a little code reader for you to make that a little bit easier, and we're going to dive into that in a minute. But, yeah. So, one other thing to keep in mind when you are out on one of these calls, if the unit is in an emergency drain, what I like to do is disconnect the pressure tube from the control board, unplug the unit from the wall, maybe 10-20 seconds, put my meter leads, put the J6 connector back in, back probe the light blue wire and the white wire for AC voltage, leave the pressure tube disconnected, plug the unit back in. If you're getting 120 volts with the pressure tube disconnected, the control board has likely failed. Now, one other thing to keep in mind is on some of these ones, the emergency drainer will run for about 10 minutes and then cut out. A lot of the times I don't want to sit around for 10 minutes if I'm suspecting something, but if you're trying to be thorough with it, let it run for 10 minutes. If it's still not dropping that 120 volts, then you've got an issue with the board. One other thing to keep in mind is that if you got 120 volts there and your drain pump's not running, you've got a broken wire because you've got an open line, then that's our control board failed, unless it's just running all the way through. So sometimes a shorted wire can cause board failure, and the unit just stays in an emergency drain. So let's take a look at our service pointer. If you do find a broken wire on the drain pump, pay close attention to what that service pointer goes over. They recommend adding those clips for strain relief right there, and it's got the part number for that. So one other thing to show you real quick is just those code readers. So basically what you do is you just come over to the one, and we offer these for free, anybody that visits the website. And basically you can just select what you're seeing on and off, and it's going to show you what that code is. And we've got a few different models up here, different configurations. They all pretty much do the same thing. Binary code simply is your F code, E code, and then 8421. This simply just adds it up for you, makes it nice and visual. All right, so if the unit's refusing to start a cycle in normal mode, but certain operations do work in diagnostics, then you want to zero in on what load is not working. If the unit's full of water not draining, you can often disconnect the pressure tube to get the lid open without breaking it, and on the units listed in the service pointer, more often than not, it's not the control board. Remember guys, as appliance technicians, your job is to go out there and actually make checks, not just throw parts at it because you think that's going to be it. If you're testing it, if the drain pump is getting 120 volts to the drain pump and it's not kicking on, then yes, it's probably your drain pump. If the control board is sending 120 volts, but that 120 volts is not getting to the drain pump, then your wiring is the issue. If you're getting open line from the control board when testing the drain pump circuit, but you're getting 20 ohms at the drain pump, then guess what? Your wire harness is bad. It's not the control board, it's not the drain pump, it's not the lid lock.